right, we're going to take notes on solving radical equations. So we're going to start by doing a general approach to solving, which will work most of the time. So number one, you always want to simplify both sides of the equal sign. Step two, this is where you're going to add or subtract to isolate the radical, which means it will be alone on one side. Number three, if convenient, so you get to decide if you do this or not. If convenient, eliminate scalars by multiplying by reciprocals. So you kind of have to decide if it's worth moving it or not. Okay, so step four is the big step. This is where we eliminate the radical. And the process we use to eliminate the radical is exponentiating, very long word, exponentiating to the same power as the index. Exponentiating to the same power as the index. And when you do this, you have to do the entire left and right of the equation. You can't just do the part you want to get out of the radical. You got to do the whole equation when you exponentiate. At this point, you want to ask yourself, is there one answer or two? If you have an even index, like a square root or a fourth root or a sixth root, then you will get a plus minus x or absolute value x, which will create two answers. If it's an odd index, then it's only going to create one answer, not two. All right, so now that we have exponentiated, we're ready for step 5, which is to solve for x. And depending on what the power is on x, you could do regular linear solving, you could factor to solve equal to 0, or you could do the quadratic formula equal to 0. And you'll have to decide which of those three solving methods is appropriate. Okay, step 6. Really important, you need to check for extraneous solutions. Check for extraneous solutions. All right, so if you have an even index, so a 2 or a 4, let's say that you got the number x equals -6. If you have a square root of x, when you sub the 6 in, you have a square root of -6. You cannot have a negative under an even index. So that would indicate that your -6 is extraneous. So even index, you cannot have a negative number under the radical bar. Now, if you have an odd index, this is a totally different situation. Let's say x equals -8. If you have the cube root of x, so an odd index, when you substitute in, that will be the cube root of a negative number. Well, -2 times -2 times -2 equals -8. So that is legitimate. So if the index is odd, 3, 5, 7, 9, negative numbers are going to be okay. All right, Roman numeral 2, we're going to do some practice problems. We'll start easy and go more challenging. So our first problem is 5 minus the fourth root of x equals 0. So step 1 is simplify, but there's nothing to simplify. Step 2, add or subtract to isolate the radical. I'm going to put the radical on the right. So I'm going to add fourth root of x to both sides. That gives me 5 equals the fourth root of x. There is no scalar in front to worry about. All right, so that was step 3. There's no scalar. So step 4, exponentiate. That means you're going to raise the entire left to the power of 4, which is the index, and the entire right to the power of 4. So 5 times 5 times 5 times 5 is 625. When you exponentiate, you're basically making 4 fourth root x's, which we can then combine into the fourth root of 4 x's. And exponentiating works because we now have 4 x's under a fourth root. So 4 x's, 1 comes out, and it is positive and negative because the index is even. So I have plus minus x equals 625, which means that x equals positive 625 and negative 625. Now, here is where we're going to check to see if either one of those is extraneous. So going back to the original equation, I do have an even index, which means you can't have a negative number with an even index. If I substitute the negative 625 in there, I will have a negative number under an even index. So this one is extraneous. And there is only one correct answer. X equals positive 625. All right, let's do another one. Example 2, 3 times x to the 4 thirds equals 243. Okay, first of all, simplify, but there's nothing to simplify. Second of all, add or subtract to get the radical by itself. It's by itself. Now, we're going to remove the scalar. It's convenient in this case, so we're going to multiply both sides by a third. So the x to 4 thirds is now alone, and 243 divided by 3 is 81. Okay, so now we're going to exponentiate to the power of the index. Remember that the bottom number is the index, so that's an index of 3. So we're going to exponentiate to the power of 3. On the left, power to a power rule, when you multiply those together, so 4 thirds times 3 over 1, the 3's divide out, and I have x to the 4th. On the right, I have 81 cubed, which is probably going to be a very large number. Okay, so we got the index out of there. We now have x to the 4th. And then this is where we need to take a square root of both sides. We don't always have to do this, but it is an x to the 4th. So we need to take a square root of both sides with an index of 4. 4 x's, 1 comes out. The index was even, so it's plus and minus. Now, for the fourth root of 81 cubed, 81 is 9 times 9. And I have 3 of those. So I have 9 times 9 again, 9 times 9 again. So 4 9s, 1 comes out. Now I've got 2 9s left. 9 is 3 times 3. 9 is 3 times 3. 4 3s, 1 comes out, gets multiplied by the 9, which is 27. So plus minus x equals 27. So x equals 27 and negative 27. Now the question is that negative going to be a problem? But it isn't, because the index was odd, and you can have negative numbers under an odd index. So this one has 2 answers. They are both legitimate. All right, example 3, double radicals. Here we go. Square root of 4x plus 28 minus 3 square root of 2x equals 0. Okay, in this case, it's impossible to isolate both radicals at the same time, so we're just going to isolate one of them. I usually do the more complicated one first. So I'm going to add 3 radical 2x over to the right. So now I have square root of 4x plus 28 equals 3 radical 2x. Now, in this case, taking the 3 scalar off is not productive because that will just give us a fraction over here. So we're going to leave it where it is. We're going to exponentiate both sides to the power of 2 because my index is 2. So 2 4x plus 28, 1 comes out. And we're going to use our absolute value bars because it is positive and negative. So absolute value 4x plus 28. Now, over here, when you have a scalar and you exponentiate, the 2 gets used with the power of the scalar as well as with the radical. So 1 times 2 is 2. So I have a 3 squared now out front. And 2x's, 1 comes out, it is positive and negative. Okay, so now we've got absolute value left, absolute value right. If x makes both of them positive, then we have a positive. If x makes both of them negative, the negatives will divide out. So in this case, we can do 4x plus 28 equals 3 squared, which is 9, times 2, so 18x. And this is just regular solving, so we're going to subtract 4x. And that gives us 28 equals 14x, so obviously x equals 2. 2 does not create a negative under this radical. 2 does not create a negative under that radical, so it's good. Again, this one had a plus minus on the left and a plus minus on the right, so there is only the one solution. All right, example 4. Cube root of x plus 3 minus 2 equals 0. Okay, add or subtract to get the radical by itself, so we're going to add 2. So cube root of x plus 3 equals 2. Now we're going to exponentiate to the power of 3 because that's our index. 3x plus 3 is 1 comes out. It's an odd index, so it's not plus or minus. It's just x plus 3. 2 cubed is 8, so x equals 5. And again, with an odd index, it doesn't matter if you create a negative under the radical. So that's a good answer. Okay, example number 5. We're going to do 2 more and then we're going to wrap this up. So example number 5. This one is the square root of x minus 7 equals negative 1. Okay, in this case, the radical is already isolated. There is no scalar. So we're going to exponentiate to the power of 2. And this is where you have 2 of those. 1 comes out, but that is positive and negative when it comes out. And negative 1 times negative 1 is positive 1. So on this one, you need to split it, where you have a positive x minus 7 equals 1 and a negative x minus 7 equals 1, just like we do with absolute value solving. So the positive doesn't change anything. So x minus 7 equals 1. We add 7 and we get x equals 8. On the second one, we distribute the negative. So negative x plus 7 is 1. Subtract 7 over to the right. Negative x equals negative 6. So x equals 6. Now let's look at what we've got. 8 substituted in does not create a problem. 8 minus 7 is 1. However, the square root of 1 is not negative 1. It's a positive 1. So 8 is extraneous because it doesn't make the left equal the right. Let's try the 6. 6 minus 7 is the square root of negative 1. We can't have a negative under a radical, so that one is also extraneous. So x equals 8 and x equals 6 are both extraneous. There are no more solutions, so this one is a no solution. List your extraneous answers, but then the whole thing is no solution. Sometimes the left won't equal the right, so you do have to test out most of your answers. Okay, Last one, square root 2x minus 3 equals the square root of x plus 7 minus a 2. Now on this one, it's impossible to isolate both radicals, so let's just leave it the way it is. We're going to exponentiate to the power of 2, entire left, entire right. 2x minus 3 is 1 comes out, equals, okay, and this is being multiplied. Radical x plus 7 minus 2, radical x plus 7 minus 2. So radical x plus 7 times radical x plus 7 is x plus 7. Then I have radical x plus 7 times 2, so minus 2 radical x plus 7. Negative 2 times radical x plus 7 is another negative 2 radical x plus 7. And then negative 2 times negative 2 is positive 4. So we're going to have a radical left, so we need to isolate it again, and this time isolate the new radical. So let's clean this up a little bit. I can subtract x over to the left. 7 plus 4 is 11, so I'm going to subtract 11 over to the left. So I get x minus 14 equals, and when you add these two, you get negative 4 radical x plus 7. All right, we have the radical term isolated. It does have a scalar, but if we divide by negative 4, we'll get lots of fractions. So let's just leave it where it is, and we're going to square both sides. So on the left, we now have x minus 14 times x minus 14, which ends up being x squared minus 28x plus 196 when you simplify it. On the right, this 2 goes to the 4, so I have a negative 4 squared. And then 2x radical x plus 1's 1 comes out. So this is going to be positive 16, and I'm going to distribute it and get 16x plus 112. Now, since this has an x squared, we're going to need to set this equal to 0 to solve it. Hopefully it factors. So I'm going to subtract 16x to the left. I'm going to subtract 112 over to the left. That gives me x squared minus 44x plus 84 equals 0. And this ends up factoring into x minus 2 times x minus 42 equals 0. So set each of those equal to 0 and solve. We get x equals 2 and x equals 42. So let's check these out. The 2, 4 minus 3 is 1. Square root of 1 is 1. Okay. 7 plus 2 is 9. Square root of 9 is 3. 3 minus 2 is 1. So 1 equals 1. That one's a winner. Now with the 42, 2 times 42 is 84 minus 3 is 81. That would be 9. 42 plus 4 is 49. Square root of 49 is 7. Minus 2 is 5. So we have a 9 and a 5. Those are not equal to each other. So 42 is extraneous. And we just have one answer left. Okay, that is it for the day. Now time for questions.